Hi there. In this project, we analyze a dataset containing information about Olympic teams from various countries over the years. Our main goal is to understand the factors that influence the number of medals a team wins in the Olympics. So, by exploring and analyzing this data, we can gain insights into how different variables, such as the number of athletes, their average age, height, weight, and previous medals, won correct with a team success. So, without any further delay, let's get started. So before we start, I need to import some libraries like NumPy, Pandas, Matplotlib, Seaborn. And to ignore the warnings, I have to import warnings library also, right? So let's get imported. Okay, fine. I have imported the libraries. Now I need to import the dataset. For this, I have to go there. Now open it. So I have my dataset. Now I have to read this dataset by using pandas library. So I'm gonna store this dataset in df variable. So df is equal to pd dot read underscore csv. Okay. So here I have to copy the path and paste it over here. Right. Now let's just see the dataset. So execute it. Here is my data set, right? I have team column, country, year, and others columns. Now, if I just want to see the shape of the data set, I mean how many rows and how many columns I have in this data set. Okay, so let's just check df dot shape. Okay, so the output I got 2144 and 11 column, right? Okay, so I can, let me just see the all the columns of this data set, right? So df dot columns, here I don't want to work with this data, with these columns. That's why I am just make another data set where I don't need to insert this column, right? So for this, I'm gonna write df is equal to df square bracket, and then let me just copy this, Ctrl C and Ctrl V, right? Okay, so yeah, now let's execute it. Fine. Now let me just check the dataset is okay or not. So df dot shape. Okay, so before we got 11 columns, now we got 10 columns because we did not take this previous 3 medal column, right? Okay, so let me just check the info, right? So df dot info. Okay, so I think everything is okay. Now let me just check the null values. How many null values are present in this data set, right? So for this, I have to write df dot is null. So we notice that the previous medal columns has some missing values. So in here, we fill these missing values with 0, assuming that no data means no medals were won previously, right? So let me just replace it with 0. Basically fill null with 0. So df square bracket. Now, okay, I just write a wrong spelling, df. So I want this column, previous medal column, right? So previous medal column dot fill null with what? 0, right? And I'm gonna store this into this column, right? So okay, now let me just execute it. And now let me just check this portion. Okay, now our dataset is ready. Now let me just plot a bar plot to see the dataset, basically how my dataset looks like, right? So yeah, let me just group the country over the medal, right? So medals. I'm gonna group my country column with medal column, right? And then I'm gonna sum it, right? Okay, I don't need this receipt index, and my I just want to top 50 column, right? So let me just write top 50 country is equal to this portion, medals by country. Okay, I got the suggestion. Let me just take it. Medals by country and then values, and yep, I don't want to sort my dataset into this ascending, right? And yeah, here is 250, as I want to show the first 15 bars or first 15 countries. Now let me just tell them that I want the bar chart, right? So is dot plot is equal to kind equal kind. Okay, I got the suggestion, kind equal bar right. Now I have all the suggestion. Let me just take it. So I want x label. X label means this portion, right? Horizontal portion. This is the x label. So I have x label is country and y label as total marks, and I have the title top 15 countries with most medals, right? Now let me just show this. Okay, I got an error in here. Let me just find it out. So okay, I think this is the problem, right? Okay, I got all the 15 countries. Okay, let me just give it a color, right? So just define a color. Color is equal to SNS dot color palette. Okay, pastel. No, I wanna take the deep, right? And let me just set the color in here. color is equal color. Let me just give it a name, the colors, and here colors. Nice. Now let me just execute it. Okay, I got my chart, right. Here is my first 15 countries that own the medals. Okay, nice. Okay, so to understand how different variables are related to the number of medals won, we need to calculate the correlation matrix. But before that, we need to create another data set called numeric DF. Right, so let me just create another data set. DF dot, I need to select the data types, right. Okay, let me just take the suggestion. So df dot select d types and include is equal np dot numbers. I wanna only take the numbers column, right. So yeah, let me just then okay, then core underscore matrix okay, I got this. I don't want this. Core underscore matrix numeric df dot core, right. Now let me just show this. Okay, let me just take this and execute it. Select. Okay, I have again making mistake. Select. Okay, I got the heat map, right. Okay, so here I can see the relation between two columns, right. So events column and this is events column, but events column and athlete column has a strong correlation as it is on the red portion, right. Okay, so +1 means strong correlation and 0 means no relation, right. So I have also, if I just take this column is what, previous medal column, and this is medal column. So these two columns has the these columns has a strong relationship, right. Okay, now let me just see the individual correlations. So for this I need to take the numeric column, numeric underscore df dot core, and I wanna use with the medal column, right. Okay, so I don't need to use this. Okay, now let me just execute it. Okay, let me just take the sort values. Okay, nice. I got the percentage that previous medal column has a strong correlation with the medal column, where we can see in this heat map. Again, athlete column has a strong correlation with the medal column. Also event column has the correlation, but height, weight, these are the minimum correlations, so we don't wanna take this. So by using this we can clearly see the relationship between the medal column and the other columns, right. Now let me just plot a linear regression line. Basically I wanna plot a scatter plot with a linear regression line. So let me just plot it. So for this I'm gonna use the Seaborn library sns dot plot. Then I'm gonna take the variable x is equal to what? I'm gonna take this athletes column, right. So x is equal to would be athletes, and my y would be, okay, let me just y would be what? Medals column, this column basically, right? Okay, so now let me just tell them which is what is my data. My data set is basically df. Now I want the linear regression line, that's why I need to tell them that fit underscore is equal to true, right? I want the line, linear regression line basically, and c is equal to would be null, right? Now let me just execute it. Nice. So here we can see that our SNS plots has an linear regression line, and we can clearly see that athletes and medals has a strong correlations. That's why we can clearly create a scatter plot with a linear regression line. Let me just plot another columns, right? So this time I wanna plot this column, previous medal column, medals with previous medals, right? So let me just copy this line from here and paste it over here, and this time I wanna change the columns with previous medals, right? Athletes, replace it with previous medal. Now let me just execute it. Okay, I got my plot. So in this graph we can also see there is a strong correlation between the previous medal columns and medals column, right? Now I am also want to plot another column. So, and this time I want to replace the previous medal column with which column? Events column, right? So let me just take this, copy this and paste it over here. Okay, execute it. So yeah, we can see there is a relationship between events and medals. Nice. So now we visualize the relationship between the numbers of athletes and the numbers of medals using a scatter plot with a regression line. Nice. Now let me just see the values of the year date, right? That how many data we have so far for this based on the year column. So df dot, so df not df of year column, and I wanna what? I wanna extract the values. Okay, so values, yeah. Here we can see we have data set from 1964 to 2016. Now our dataset contains data from 1964 to 2016. So I decided to train the model using only those data that are less than 2012. So here I'm gonna copy only those data basically for the training, and for the training that are basically those data are basically before 2012 for training, and I'm gonna use the test data on that are basically 2012 onward for testing, right? So I'm gonna copy those data set for the training and testing. Now let me just create two variables. One is train and another one is test, right? So for training, I'm gonna take the data set. Okay, let me just take the suggestion. So here what I have done. Okay, I wanna copy this, right? So let me just copy. So here what I have done, I am just taking no, not 2016, I wanna take 2012 data. So here I wanna take 2000 before the 2012 data as training purpose, because we wanna train those by using those data that already we know this country has won, right? So we wanna use those data for training purpose, and from 2012 to 2016 data as test data, right? Okay, so let me just execute it. And now let me just train the and now let me just see the shape of the train data and test data. So train dot shape, right? Okay, so we got 1734 rows as train, and 10 rows, 10 columns. And let me, if I just wanna execute test shape, test data set shape, here we got 408 rows and 10 columns, right? Now let me just build a model. I wanna use a linear regression model. So for this I'm just gonna import the linear regression library, right? So go to here and just import. Basically import the linear regression model from sklearn scikit-learn library, right? So let me just import, no, let me just write from sklearn dot linear underscore model. Okay, I got this suggestion. No, I don't wanna take this. I just wanna mean absolute error, right? So from sklearn dot matrix I wanna mean absolute error only, nothing else, right? Now let me just execute it. Okay, I have done a mistake. From sklearn dot matrix input, no, mean, not mean square error, mean absolute error. I want mean absolute error. Okay, nice. I have imported the necessary libraries for building the model. Now let's go back to here and write the variable where we want to store our linear regression. So linear regression, right? And let me just write down the predictors. Basically predictors is equal to which I wanna take basically these columns. Let me go back to the okay, I can just write it down. df dot columns. I wanna take athletes, basically athletes, this column, then previous medal column, and then events column, right? Okay, and also let me just say the target is equal to medals, right? And now let me just feed the predictors and target, right? Okay, so let me just execute it. Okay, I have successfully fed my linear regression model. Now let me just see the predictions, right? So for this I have to write predictions. I'm just gonna use the predictions variable uh, predictions is equal to would be my regression as predict as I'm just gonna predictors of test dataset, right? Okay, and for this now let me just take nice. Now let me just write the predictions. Let me just copy the predictions into a test of predictions column, right? So I okay, now as I got the predictions, now I wanna add these predictions to the test data set for predictions column, right? So let me just take this. I'm just gonna take df of and no is equal to predictions. Okay, I got another error. Let me just see. Okay, not df, it should be test. Sorry, my bad. Okay, got it. Okay, now let me just log the prediction. Basically, if we got a value that is less than 0, we will put 0 in those values, right? So we will replace those values with 0. So let me just do it. So log test of log, and what we wanna do? No, not this. Me just log of what test of prediction. Okay, yeah. Test of prediction as less than 0 and predictors predictions is equal to we will replace the okay. So test of I'm just gonna log the test data set, and where we got the less than where we got the value that is less than 0, we are just setting or replacing those value with 0, right? Now let me just execute it. Now let me just calculate the error basically, right? So error is equal to mean absolute error, and I'm just gonna target of test data set, not target. I'm just gonna take the medals of, right? So medals of test data set and predictions of test data set, right? Now let me just execute it and see the error. Got it. We got the error is 3%. Now let me just check with our standard deviation. So for this, let me just write it df.describe with which column? Medal column, right? So medals. Okay, nice. So here we can see our standard deviation is 33 and our error is 3%, which is far less than the standard deviation. Sorry, this is my pet just. Okay, so now let me just check the actual values and prediction values. So for this, I'm just gonna take the test of team, basically test of um, test of team is equal to USA, and I'm just gonna set it with the df value. No, not TF value, test. Right, now let me just execute it. Okay, I got another error. Oh shit, I have to write equal. Okay, so our actual values is 248 and our prediction is 274, where also another rows you have said 264, but we got 238, which is okay, that is not too far, right? So yeah, so let me just calculate the errors. So errors is equal to absolute value of this data set of what? Metals column, right? Okay, metals column, and I wanna okay, so I wanna subtract it with, okay, let me just take the suggestion. I don't want this, right? And yep, let me just execute it. Okay, I got my errors now. Okay, so let me just write error underscore by team, and let me just take the suggestions error, basically error by team, and let me just copy this and paste it for the second time, and this would be metals by team, right? This would be metals by team, metals by team, and this also metals dot group by of team, and not ascending equal false. And now error underscore ratio is equal to, now let me just divide error by team with metals by team, right? Okay, execute it. Details metal. Now let me just execute it. Okay, fine. Now our error ratio would be infinite, right? So this time we just want to take it as finite. That's why we need to use the numpy library to make it finite. Basically error ratio, we want error ratio as finite value. So our error dot ratio of what? np dot is now, sorry, is finite, is finite of what? Error ratio, this basically. So error ratio, and we wanna put it back into the error ratio. Now let me just execute it. Okay, so we have done a mistake. Let me just see. Okay, error underscore ratio, error underscore, yeah, just making the stupid mistakes, I'm sorry for that. Okay, we have calculate our error ratio. Now if we just see this, what is our error ratio? So our these are the error ratios, right? Okay, now if I just wanna plot this error ratio, then how it looks like, let's just see, right? So for this I'm just gonna error ratio dot plot dot hist, and my color would be sky blue. Color is equal sky blue. Okay, so sky blue, and my edge color would be black, right? And now title, now okay, I get the auto suggestion. So my title would be histogram of error ratio. Okay, error ratio distribution, no problem. And my beans, so let me just take the beans is equal to be 10. Okay, and x level would be error ratio, y level would be the frequency, right? And let me just show this. Okay, so yep, plt series object has no attribute or plt. Oh, this would be plot, right? Plot dot hist. Again in mistakes ratio, color, okay, so we got our plot, right? Now if I just sort our error ratio values, so error underscore ratio dot sort underscore values, right? So if I just wanna sort these values, okay, this is our error ratio. So yeah, in this project we analyzed a dataset containing information about Olympic teams from various countries over the years, and the model's mean absolute error on the test was 3.22 medals, and given the high variability in medal counts, which is mean is equal 10.56 and standard deviation was 33.03, this error is reasonably small, right? So this analysis highlights the importance of historical performance and team size in predicting Olympic success. While the model performed well for many teams, there were some with higher error ratios, indicating areas for improvement. So that's it for today. Thank you for following along with this tutorial. I hope you find it insightful and informative. So see you in my next tutorial. Happy analyzing!